Alright class, today we're going to start a new unit. It's on the volume of 3D figures, and we know from previous concepts, previous videos, that there are several types of 3D figures. We're going to focus first on polyhedra, which include prisms and cylinders. But before we do that, let's take a look at the definition. Volume is the number, so it's a number, of cubic units contained in the interior of a solid. So I want to really point out that when we talk about cubic, we're talking about the dimensions should be normally cubed, unless you're talking about something like milliliters, which is a volume dimension which represents so many meters cubed. But when we say cubed, it means raised to the third power. So we talk about centimeters cubed. But we don't say the same thing about milliliters because that's already a volume unit. So we're going to go over some common formulas to find volume. Really, to find the volume of any prism, it's really the easiest because you take the area of the base and multiply it times the height. So if this was a piece of paper, to figure out the volume that could fit, of number of papers that could fit in this box, you take the area of one paper and multiply it times how high or how many papers were in the box, and that's the volume. Since we are talking about a cube, then the sides of all a cube are congruent, so the area of this base is going to be this length times this length, and the height times the height is the same length, so that's why we call it S cubed, because everything is the same. If two polyhedra are congruent, then that must mean they have the same volume. So if all the faces are congruent and all the dimensions are the same, then that means the polyhedra also has the same volume. And then if I want to find the volume of a figure that I don't have a formula for, if I can find the volume of the non-overlapping parts and add them all together, then the sum of the volume of the non-overlapping parts is the volume. So when we're dealing with a prism, the area of the area of the base times the height. In this case, now we have just B, which is the base shape. We find the area of that shape and multiply it times the height, and that really will give you the units cubed, because this isn't squared and this is height. But what if I don't have a prism but I have a cylinder instead? That's pretty much the same, because in this case the base of this shape is a circle, so the area of the base is pi r squared, and we multiply it times the height and you get the same volume. Okay, same volume type formula. Let's take a look at the next page. Now that we're dealing with pyramids and cones, the formula for volume is a little bit different. It still involves area of the base times the height, but now we're not going to take the full area of the base times the height, because as you can see that a pyramid doesn't have the full area of the base moving upwards. It has a portion, and so they've calculated that it's a third of the area of the base times the height. So in this case, to find the area of a pyramid, the volume of a pyramid, we take 1/3 of the area of the base times the height. To find the volume of the cone, it's the same principle. The only difference is that the base is no longer a square or a polygon, it's a circle, and the area of a circle is pi r squared. So over here, area of the base is pi r squared times the height, and because it's a cone and not a cylinder, we have to include the 1/3. So 1/3 of the area of the base times the height is the volume of the cone. Now some shapes are not right cones or right cylinders, but Cavalieri's principle says if two solids have the same height and they have the same cross-sectional area, which means if I take a slice, the area of that slice at every level, then they have the same volume. And we'll take a look at that in an activity in class. And we can't forget the volume of a sphere, which is a non-polyhedron. We still find the area of the base, but since the sphere really doesn't have the area of the base, we just find the area of the circle, and then we multiply it times the height, and the height is really a combination of bases, a combination of radii. This is r and this is r. So the formula for the volume of a sphere is 4/3 pi r cubed. Okay, let's move on to the next form. Let's look at some examples on page 166 from the note-taking guide. Find the volume of prisms and cylinders. So here we have on the left a right triangular prism, And let's try and find the volume of that. Well, in order to identify that, we know that the shape is a triangular prism, so which means the base is a triangle. So we have to find the area of the triangle first and then multiply it times the height. And in this case, the height, i.e. the distance between the two bases, is 2 feet. So the area of the base is 1/2 base times height. Since this is a triangle, it's 1/2 1 times 3. So the area of the base of this triangle is 3/2. And the height is 2 feet. So we plug that into our formula. Area of the base times the height, 3/2, which is the area of the base, times 2, which is the height. And we get 3 feet. And notice the units. It will start off in feet, but the actual units is cubed. So that's very important. Now let's talk about the right cylinder. We still use the volume formula of area of the base times the height, but in this case the base is a circle and the height is the distance between the two circles. So to find the area of a circle, it's pi times 5 squared, which is 25 pi, and to find the volume we just plug it in. Here we have our area of the base, which is 25 pi. And we have our height, which is 6 meters. And so we multiply that together and we get exactly 150 pi, or around 471.24. And again, cube. You don't forget the cube part, because it's a number of cubic units. So that means around 471 of those unit cubes will fit into this shape. Okay, well, around 3 of these unit cubes, feet cubes, will fit into this shape. All right. So we're going to use this to find the volume of a right cylinder. Now I know you guys are saying, oh, this is easy, and you're right, because that's middle school stuff. Now we're going to do the more high school stuff, which is we're going to work backwards. If they give us the volume of a cylinder, how can we find the value of one of the pieces or dimensions of the shape? Well, we have to work backwards, and that's using algebra. So we know that the area of the base is pi r squared, but since we don't know what the radius is, and we say that's x that you're trying to solve, we can replace it as pi x squared in the formula for volume of a cylinder. So b times h, or pi times x squared, which is the base, as we can see, times the height, which they do give us, and we set that equal to 1253 because they give us the volume. We don't have to solve for it. And now we have to find what x is. So now it becomes algebra. Try and get x by itself. We can rewrite it. We can divide both sides by 10 pi, and so we get x squared is equal to 1253 over 10 pi, and then that's roughly around 39.88. And then take the square root, because it's x squared, and we get that the radius is about 6.32 centimeters. Okay? All right, let's go take a look at cones. Okay, so let's find over here on page 168 an example. Find the volume of the pyramid. Now we're dealing with the pyramid with the regular base, so that will help us out because they said regular base. So in order to find the volume of the pyramid, we need to figure out first the area of the base, just like what we did in the previous example. But in this case, we don't have a base that we have a general formula for, but they did tell us it's a regular base. And so since we know regular means all the sides are the same, we know the formula for the area of a regular polygon is 1/2 a times p, where a is the apothem. So we have a, and p is a perimeter. So we can figure out the perimeter since they tell us the sides are all 4, which means the perimeter is 24. And then since we have an apothem, we can do our right triangle trigonometry or special right triangle to figure out the length of the apothem, which is in this case 2 square roots of 3. Okay, and we plug that into the formula. Area of the base, which means 1/2 a times p. So here is our 1/2 a times p, and we get our final answer, which is 24 times the square root of 3. And they say it's inches squared because we're talking about area. And then since we're trying to find the volume, now we can plug in the correct formula. 1/3 area of the base, which we says was 24 square roots of 3, times the height, which is 10. And you get 80 square roots of 3, which is approximately 138.56. So the volume is 138.56 cubic inches. And that ends this video.